Hello, welcome back. In this video, we're going to continue our discussion on using Desmos to help us with particle motion questions. In example number 2, we're told that a particle moves along the x-axis so that at any given time t is greater than 0, we're given the following velocity. V equals 3 plus 4.1 cosine 0.9t. And we are asked what is the acceleration of the particle at t equals 4. So I have a couple of options here to solve it. Option one is I can just take the derivative. It's not that hard of a derivative to take, and then just plug in the 4. But since we're allowed to use Desmos here, this really doesn't take too much work at all. Because in order to get the acceleration at 4, we just have to find the derivative of the velocity at 4. So if I go over here to my Desmos, I can just go ahead and type in my velocity equation. Now, we are going to use f of t equal, and I'm just going to type it in, 3 plus 4.1 cosine 0.9t. And there's my graph. I want to find the velocity or the derivative of the velocity at 4. So if I just go down to the next line, all I have to do is type in f prime of 4, and I get this 1.6329. I'm going to round it to 1.633 because we like to round to 3 decimal places here. So this becomes just 1.633. Now, if you notice, we have all of the space down here. So you might be asking, well, with all that space, why is it such a short answer? Well, that's because not everybody necessarily has a calculator, so they have to take the derivative itself by hand. And that's in the case. But in this case, we don't have to. So we can just use Desmos to get the answer, so we don't really need all that space. All right, question 3 is always a fun one. It says a particle moves in a straight line from 0 to 5. The velocity is given by the following equation. -2 plus t squared plus 3t to the 6th minus t cubed. And we want to know, is the speed increasing or decreasing? So we are talking about speed here. All right. Oh, hold on here. Just kind of froze out there. Let's see if that works here a little bit. Nope. Hold on. There. Let's see. We kind of froze out right there. So, oh, there. Pardon. Sorry. Kind of froze out there for a little bit. There we go. And let me get back to my Desmos here. Split view and Desmos. Sorry. My computer kind of froze on us right there at that moment. So we're looking for speed here this time. And you might remember, we want to know if the speed is increasing or decreasing. So anytime we think like speeding, like increasing or decreasing, or speeding up, slowing down, we're actually needing two pieces of information. We need one, we need the velocity, in this case at 4, and we need the acceleration at 4. Now, since they gave me the velocity at 4, I can just get that from the graph. So if I go over here, I'm going to type in my new velocity equation. Again, I'm going to use f of t here, and that's going to be -2 plus, open up some parentheses, t squared plus 3t, and that's going to be raised to the 6/5, caret 6 divided by 5, and then we're going to minus t to the third. Notice how ugly this is because they're saying they really don't want you to take the derivative here by hand. So there's my velocity. So to get the velocity at 4, all I have to do is just type in f of, not t, but 4, and I get this -11.476. And to get the acceleration, we want the derivative of the velocity at 4. So to get that, I type in f prime of 4, and I get this -222.296. Now, if I want to find out if it's speeding up or slowing down, if the speed is increasing or decreasing, I'm going to look at the signs here. Notice the velocity is negative, and so is the acceleration. So what's going to happen here? So my velocity and acceleration are going in the same direction. So in this case, the speed is actually increasing right here because the velocity and the acceleration is going in the same direction. And so that's what we would put at t=4. The particle is speeding up, or the speed is increasing, speeding up. And this is because the acceleration at 4 and the velocity at 4 are the same signs. Anyway, I hope you enjoyed this video, and if you do, give it a thumbs up, smash that like button, and I will see you next time. Thank you.